So in today's lecture, we shall write the Verilog module for one bit comparator by using case statement. Already we have written the Verilog module for one bit comparator by using if-else statement, but here we will use the case statement to write the Verilog module. And after that I will demonstrate you the software by using the test bench of this one bit comparator. So here this is the block diagram of one bit comparator. So there are two inputs, A1 and A0. So intentionally I have created these two inputs as a vector because I know that since I am going to use case statements, so in the case statement the expression should be a discrete type or array type. So due to that reason only I have created here the array of two elements as a input, right? So here the inputs are A1, this is one input, and second input is A0, right? So these two bits will be compared, and depending upon these values of these two bits, out of three outputs any one output will be high. So if A and if two means A1 and A0, if these two numbers are equal, then the output Y0, this will be high, right? So this output Y0 will be high. So Y0 will be high if A1 is equal to A0. Now if A1 is less than A0, then Y1 will high. So Y1 will be high when A1 is less than A0. And if A1 is greater than A0, in that case Y2 will be high. So Y2 will be high if A1 is greater than A0, right? So now same thing is shown in this truth table. Here A1 and this is not B, this is A0, right? So A1 and A0 are the inputs, and the values of these inputs are compared, and depending upon these values the outputs Y0, Y1 and Y2 will be set or reset. So in the first row, if A1 is 0 and A0 is 0, then Y0 is 1 and remaining two outputs are high. In the second condition, if A1 is 0 and A0 is 1, means A1 is less than A0, in that case Y1 will high and Y0 and Y2 will be 0. Now third case, if A1 is 1 and A0 is 0, means A1 is greater than A0, in that case Y2 is high and remaining two outputs are 0. And the last case, when A1 is 1 and A0 is 1, means both numbers are equal. So again y naught will be 1 and remaining two outputs are 0. So now the Verilog module for this particular functionality is like this. So we start with the keyword module and we end with the keyword end module. The name of this module is comparator underscore 1 underscore bit. A and Y are the ports. Now I am declaring the input ports. So for that I am using keyword input. Now I am mentioning the range because I want to create the vectors. So range is 1 colon 0 A. So with this my A1 and A0 will be created, right? So here I will write A1 and A0. These two elements of the vector will be created in this sequence only. A first A1 and then A0. Then output 0 colon 2 Y. So with this the output vector will be created, and this output vector is I'm writing here Y, Y0, Y1, Y2. So these three elements of Y will be created in this sequence, right? Because we have created output vector as 0 colon 2. So first Y0 will be there and then Y2. Okay. After this I have declared rect type 0 colon 2 Y. So Y is declared as rect type because in the always block I am going to assign the values to the Y. That's why I have declared it as rect type. Then always at the rate within bracket A. So A is in the sensitivity list of the always. So whenever there is any change in the values of either A1 or A0, then the always block will be activated and all the statements inside the always block will be executed in the sequence. So now inside the always block I have used the case statement, so that's why I am using keyword case and within bracket A. So A is the expression now, right? Depending upon the values of A, any one arm of the case statement will be executed. Okay. Okay. Now 4 statements is written here because there are in this two table there are 4 rows, one condition, second condition, third condition, fourth condition. That's why there are 4 statements, 1, 2, 3, 4. And in the last I am using the default condition also because we know that in Verilog we have multi-value system, right? So to cover all unassigned values in various arms of the case statement, if those values are there, then the default statement will be executed. Okay. Right. Now here in the case statement, see the first condition of the case. If the value of the expression, that is A, is 0, 0. So this 0, 0 indicates A1 is 0, A0 is 0. If this is the case, then what will happen? For this case, see the row number 1 of the truth table. Y not is 1 and remaining two outputs are 0. So that's why I have written this statement y is equal to 3 tick b 100. So the value assigned to the y is 100. How values will be assigned? This one will be assigned to MSB. This 0 is assigned to middle value of y1 and LSB is assigned to the LSB element of the vector. So in this way the value assigned to y will be 1 0 0. This is our requirement if A1 and A0 are 0. Okay. So first condition is over. Now we will see the next condition. Next condition is this. If A is 0 1, 0 1 means A1 is 0 and A0 is 1. So if this is the condition, then see this row second of the truth table. For this condition, y1 is high. So see what values we are assigning to y. 0 1 0. This means this 0 belongs to y2, this 1 belongs to y1 and this MSB 0 belongs to y0. Okay, this is done now. Now we will see the third condition. In the third condition, this, if the value of A is 1 0, 1 0 means A1 is 1 and A0 is 0. If this is the condition, then see the row 3. In row 3, y2 is 1. So see what value we are assigning? This 0 0 1. So 0 0 1 means 0 0 1. Y2 is 1. So this value is assigned to y. Now we will see the next condition. Now in the next condition, the value of A is 1 1. It is this 1 1 means A1 is 1, A0 is 1. If this is the case, then see this row fourth of this truth table. So y0 is 1. So see here what value we are assigning to y? 1 0 0. So this 1 0 0 means y0 is 1 and y1 is 0, y2 is 0. And if the value of this expression A is other than these four values, means 0 0 0 1 1 0 1 1, other than these four values, then this condition will be executed. If it is default case, then y will be 0 0 0. All the outputs will be 0. So this is the Verilog code of 1-bit comparator. So here this is the Verilog module and this is the test bench. This one. So in the test bench, the ports of the test bench A1 and A0, which are attached with the input ports of the unit under test A0 and A1, will be declared as a rig type, and the ports of test bench which are attached with the output ports of the unit under test will be declared as wire. So same way we have declared in the test bench rig 1:0 A, wire 0:2 Y. So in this way we have written this test bench, and here these are the various values which we are assigning to input this A. We are giving to this A at different timing, right? Now we will see the waveform of this test bench. Already we have discussed a lot about the test bench, so I am not going in the detail about this test bench. Okay. Now see here, Right. So this is the code of the comparator which just now I discussed, right? Module comparator underscore one underscore bit a colon a comma y, in this way. These are the four conditions of the expression a is 0 0 0 1 1 0 1 1. For these conditions, these values are assigned to y. So this is the code. Now I will show you the test bench, and this is the test bench. This is the test bench. Right. This is the test bench. Okay, so I will run this test bench. Okay. So see here, this is output y, y0, y1, y2, and inputs are a1, a0. So we check here at this time 6.85 nanosecond. At this time value of a1 is 0, a0 is 0. For this case we know that y0 is 1. See here, y0 is 1 and y1, y2 both are 0. We'll see the next case. Here a1 is 0, a0 is 1. So this means a1 is less than a0. For this case y1 is 1. So see the output y1, this is 1, and remaining two outputs are 0. Y0 is 0, y2 is 0. We will see the next condition. So now next condition, a1 is 1, a0 is 0, means a1 is greater than a0. For this case y2 is 1. So see here y2 should be 1, it is 1 now, and y0 is 0, y1 is 0. We will see the next condition. Next condition is a1 is 1, a0 is 1, means a1 is equal to a0. So for this case y0 should be 1 and y1 and y2 should be 0. So see here y0 is 1, y1 is 0, y2 is 0. So in this way we have just seen that the Verilog module which we have written for a 1-bit comparator by using case statement is showing us the functionality of 1-bit comparator, right? Okay.